I'm sorry to the person on Zoom, you're muted. I just unmuted us. So thank you for your patience. So I'm going to open it up. Does anyone have a specific question yet? They can, yes.
Do you actually for real have to publish a paper in undergrad to get into grad school?
No,
I didn't publish any papers. I still have to publish a paper.
I have not published a paper.
That is a mistake.
But like you don't.
Oh, yeah, we can say, us three are experimentalists, Colin is a theorist, so in case that helps anybody.
You don't have to publish a paper to do theory also. There are people who have. There are some people who have, some people who have. It's not as important as like the process of what you do, the connections you make. Like a paper is just one way of showing, okay, you can do something. There are many other ways to, like kind of like signify that you're good at research, that you're a good person to work with. And I would argue that that's more important than like one little like check mark. It's like what's a paper published.
I think giving talks or poster presentations at conferences is a great way to both network and meet some people and to kind of demonstrate your research capabilities. And I just find it's way more fun than writing a paper.
Yeah. Guess to expand on that, you've also, I assume you're all here because you're part of our summer research program. So you've done the right thing. You have some research experience. And that is more what people are looking for on admissions committee, that you've done some research and that you can, in your essay that we asked you to write about what you learned from doing the research, not what science did you learn, but how did you figure out what you did, how that works as being research is very different to being in class as an undergraduate. So calibrating detectors has to be done. That's often what an undergraduate summer program is. Takes a long time to get that through to a paper if you've done it, but it's still, you're doing research. This is what a lot of research is. So it's not that you publish 10 papers. If you managed it, great. But that happens to be that you had the supervisor who found the topic that it worked in the 10 weeks that you did your summer research program. And most of us don't manage to publish in 10 weeks of effort. So it's more, did you do research? Did you learn from it? What experience did you gain from it? Have you worked well with others? So hopefully the person you're working with for your summer research is writing you a letter. And can they say that you were able to work with other people? And I think these type of things are much more important than you hit the home run and got something publishable out. Great if you do, but it's not the end if you don't.
I think also, especially for the Yale people, but this can be true for any summer program. There's two different things you can get out of them. One is exploring a new area of physics or astro, seeing if you like it, learning about that subfield and what the work in that looks like. And so if all you do by the end of the 10 weeks is learn that about that subfield, you've already gained a lot. And that's helping you as you look forward to what it is you want to do in the future. But additionally, you may find that you really like working in that subfield and want to keep working on that project after the end of summer. If you find a faculty member who's willing to facilitate that, into the semesters and things like that, I think that kind of commitment to a project is also great. And if you like a project and want to keep working on it, the things that you gain research-wise can be really well communicated by your essay, by the letter of rec, by any conferences or places that you go to, and potentially by the interview that you do if you make it into that stage of most graduate programs application cycle. And so, even if you are actively working towards a paper, it doesn't need to be out on archive or published by the time that you are applying for all of that work to be an active part of your application.
Yeah, I'll say briefly for myself, I'm very much more the first situation that was described. I jumped around a lot and did a lot of short bursts in one field and another, which really helped me figure out what I liked. And I did a lot of research, worked with a lot of people, but there was just never a point where a paper was going to come out of that. And that doesn't matter, Yeah,
I also agree. That was the same thing with me. I think I did a different research every summer.
Yep.
Like every summer I did something different. Like I started off in like astronomy, like doing like compact objects, and then I switched to particle physics, axion detectors and all that stuff. So it's definitely okay if you are jumping around. You just have to show that you're really committed. And if you are gonna write about it, kind of like write about it in a way that is like, what did you take away from all of these experiences and how does it make you a better researcher and make you excited about like maybe continuing to like figure out what you want in grad school, but also like why it made you interested in a specific field. Like I think after all the research, I realized I wanted to do particle physics and experimental particle physics. So I was able to like write about that. But yeah, but it's totally okay if you don't push out a paper, but it's also, I think, a good plus.
I had a slightly different experience in that I spent my whole undergrad just working for one research group because I was super lucky and I found something that clicked for me right away. But it happens that publishing in a relativistic heavy ion collaboration is next to impossible when you're an undergrad. So I did 2.5 years of work and I had some cool things to show for it, but that was just, it wasn't a paper and that was perfectly fine.
So I think I forgot to ask you, what institution did you go to and what did you major in?
I'm from University of Colorado Boulder, where I had a double major in physics and math.
I come from Wellesley College, small liberal arts near Boston, and I majored in physics and minored in Latin American studies.
I came from UC Berkeley. I majored in physics and minored in astrophysics and education.
I came from USC, the one in California, not South Carolina. And I double majored in physics and astronautical engineering, which is funny because I'm a theorist. So you can kind of tell based on that I jumped around a bit. I had like a trajectory that was not like one path.
I was also at UC Berkeley for undergrad. I double majored in physics and astrophysics and minored in creative writing.
I was an undergraduate in the University of Birmingham in the UK, and I did my PhD at the same university. That's more common in England, that you stay where you did your undergraduate. Came to Ohio State as a postdoc and stayed in America since then.
So I was an undergraduate at UC Berkeley, majored in physics. And then I did a short stint at UCLA and that was a little bit of a mess. And so, so I was a graduate student at UCLA for a year and then I came to Yale and finished my PhD here.
So is anyone here interested in hearing more about an international experience? Because, yes, all right. So, Helen, do you have specific questions or about?
I guess, what does international work look like as an early career researcher, like for example, in undergrad?
Ask the question again.
What does international research look like as an early career researcher?
So I guess, so like, we're heavy ion researchers, Morgan and I, so we have international collaborations. And normally as an undergraduate, you don't know that it's international. I mean, you have an awful lot of early morning phone conferences potentially, depending on where you are. But normally undergraduate research is being done at your home institute, like, or wherever you've been accepted into the REU program. So you'll be doing work here. It's quite rare as an undergraduate that you get sent abroad. Sometimes it happens, like CERN has a program for summer students, so you might be able to peg into that, or so other places do. So it's possible, but I think not very common, just because there's a big expense involved in flying people internationally. But it can happen.
I know that a lot of our graduate students have traveled to their experiments.
Once you're a graduate student, then you are offered
Conferences.
money. They'll send you around the globe once you're a graduate student. But mostly the
I guess what I was asking is the difference applying to an international institution for a graduate program. Is there a difference?
I get, yes, I think so. If you're in the US and you're applying internationally, I mean, some of the programs don't track quite as well of undergraduate to graduate. So it depends what classes they are looking for and whether you need to get a master's before you move on to the PhD program to sort of get to the same finishing level. Like in a lot of Europe, and I think a lot of the rest of the globe, you're majoring in physics means you studied physics and maybe branched into math from like age 16 or so. Well, we're not doing breadth program courses. You're doing physics, and more physics. So by the time you finish your undergraduate, you're at the level of, I would say, the end of classes in the American PhD system. So there's that disjoint in levels. You can fix it, they'll do things, but it tends to be how you map that through. And you tend to be in a lot of Europe, you get the sponsorship to do the graduate. And so you sort of have the money from the funding agency that you go to a university. It's much more they interview you versus the graduate school here where the students kind of interview the colleges. So it's possible, and the deadlines are different. So if you want to go international, you really have to be looking early when the different countries take their graduate students. Like in the US, it's November-ish before the year you want to start. They're quite often earlier in Europe, some are later. So that's really the bit, is you might be out of sync if you're and just too late.
Well, additionally, their acceptances often come earlier than ours and don't come with the standardized date cutoff. So in the US, pretty much all programs have an agreed upon April 15th deadline for accepting an offer somewhere. And so even in some places, even if you're on a wait list, you basically know all of your options and get to decide between them equally by April 15th. But you might find out like in December or early January that you got into a European program, or more specifically into a lab in Europe. And they'll be like, you have 2 weeks to decide to accept or decline. And so if you're trying to actively compare European offers and US offers, that can be challenging. So the people who I've seen who've been successful with going to Europe are mostly ones who knew they wanted to go to Europe for sure, really didn't apply to US programs because they knew they would be making their decisions before the US cut.
Okay.
Also, this is just, well, I was gonna try to apply to some of the European ones, but I missed the deadline. So yeah, you have to be on top of the deadlines. But I know that when I was looking into it, there's like a couple of, I know these are like the bigger schools, but I know there's a couple of like master fellowships for like international students to, I think, like Cambridge or Oxford, if that's something y'all are interested. They're like pretty known. So I'm pretty sure that if you look it up, so that's like something that if you are like from America or another international student, it probably maybe depends on the country, but like you could like look that up. Also, I know of another, it's kind of like a study abroad, and I think it's hosted by BU, if I'm correct. But what you can do is that you apply through BU, and I don't know if it's like another, but you basically spend a semester in CERN if you are interested in particle physics, but you have to have like some French requirements, like some French classes, because most of the universities there, they will teach in French. I remember I was interested in doing that because I wanted to switch over to particle physics, but I didn't have the French requirements to do that and wouldn't have been able to do it in time. But if someone is interested in particle physics, that is something that you can do, I think, your junior year of college, if you have the specific requirements. It's like a study abroad option.
Do you know if you needed the French classes, or like, what if you just self-studied really hard?
I don't remember. I didn't know I wasn't gonna self-study, so I didn't try to find a loophole. Yeah, I was gonna learn French. But I think from what I remember, it said that you to be like in a second level or like be intermediate, like at least be able to like communicate and understand classes that are being taught to you.
They might have some fluency tests too that they had to take.
Yeah, and I found out about this at like a random conference that I went to my first year. So like really look out for like conferences and even see if you can get sponsored through your like PI that you're working with, or even through Yale, because usually the like bigger conferences have a lot of opportunities. So
Heard one of you said you went to CERN. Did any of you else have any international experiences
I
yet?
didn't go to CERN. It's kind of, it wasn't through an actual program. I did 2 summers in Italy. But it was from my undergrad advisor, basically, one of her previous postdocs I worked with him. in Italy in his group for like an internship. It wasn't like any official program, but it was basically like he like paid for me to like work for him over the summer. And I guess that's kind of like how I was when I was there, I kind of did learn a little bit about how the PhD is working. It definitely is much more like you apply to work with a specific professor or some specific professor, they admit you to their group. Rather than like to the school as a whole. And yeah, it's a lot. It seems like it varies a lot more from school to school there and like from program to program, department to department. It's like in the US, everything like applications are due sometime between like December 1st and January 15th, I think. Generally, something like that, around December, January, and then you get to accept it in May. But then for Europe, it's some of them have an entrance exam, some of them don't, some of them you just like professor, some of them you don't. Yeah. I would say if you want to go to Europe specifically or really anywhere abroad, you just do your research early on into like what the specific programs you're applying to are, what the specific people you might want to work with are, and like what the policies are surrounding that.
That's probably good advice for anything.
Yeah.
Yeah, well, yeah.
I would definitely say do your research to the program you're applying to, right?
But it is like you say, it's a one-on-one, like, so you
Yeah.
need to decide, I want to apply to XYZ university to work with Professor X.
Yeah.
Whereas in the US, it's, I want to go into a graduate
Yeah.
program, and now they're very similar applications across the country, and they're the same.
Yeah.
So that's the difference, in that you have to cultivate a relationship with a faculty member in Europe versus, you can apply somewhat cold.
Yes.
So that's for abroad and US, but I'm personally interested in abroad. How do you land in formal research positions that are outside of a program, for example, with a specific PI?
Right to them. That really is how you do it, is you write to the person and say, I'm really interested, is there any way? They don't respond, you write to them a few weeks later, repeating it, because if you went outside of not answering isn't necessarily a no, it can just be you call us at a conference or something and just ask around, and if it's not this person, go one to the left and see.
It's a very well-connected community, so it is always great when you've met the person in person or you know someone who knows them. So I feel like everyone is at least like within 2 degrees separation of each other. If you want to find someone, you'll find someone who knows them at least. So yeah, talk to people, ask around, go to conferences, communicate for yourself.
See what funding there is at the institute you work at, because if you write to me and say, I have some money to help me do this, you'll become much more interesting. And it's amazing what funding there is at Yale, if you're at Yale or at your institute. It may not cover it all, but there's a lot out there if you dig away and are persistent. That's why cultivating with your faculty member at the university you're at can also help point you to opportunities. Just
I
pushing
would say
yourself.
be persistent then. Like if someone if someone doesn't respond to you, their email might have gotten. I mean, don't like email them 20 times within like an hour. But like if someone doesn't respond to you in like a week or two, like follow up, you know, like and like people aren't gonna take that as a bad thing. And like if you know people who might know them, you know, use your connections, use like get like anyone who would advocate for you, like any professors, that's
Little life hack, schedule send email for 8 AM.
yeah.
I think I've seen, sorry, the highest success rate comes from the closer of a sort of networked connection exists. So like in your case, right, like former postdoc of your PI is somewhere that they know each other, right? So in a similar way, right, if you're working with someone here who has some international connections, that's like probably the highest percentage chance place to start. But like volume never hurts either, right? So if those connections, you don't have them right now, or you know, you've tried them, but nobody has the funding to help with that, then you can really start going out. But I just wanted to throw in a pitch for things like, you know, when you're at your university and there's a colloquium speaker every week, you know, make sure you like are going to their talk and meeting them and introducing yourself. It's a little bit scary, but it's definitely, you know, I found as an undergrad that by going to colloquium dinners from time to time, or actually getting to meet people, that really helps. Then you meet them at a conference. Then when you go to email someone at their institution later, you might actually email them first and be like, hey, I really enjoyed meeting you and so and so. I was wondering if you might be able to introduce me to this person. And so, those connections of people who know people tend to be where a lot of these opportunities arise like a little more naturally than just having to cold email like a lot of people. But cold emailing is always the fallback.
And it really is cultivating relationships with your faculty here, because you have your gossip channels, we have our gossip channels. So, like people have said, if I write to a colleague that I'm friends with and say, you should really take undergraduate X, they're fantastic, you're much more likely to do that than you cold calling. So that means you've got to know me well enough for me to take the effort to write the email. So go to office hours. It doesn't have to be that you're failing the class to turn up to office hours. Because if I know you and know that you're interested in going to grad school, even if it's not the topic I do, we have connections, as people have said. So I think getting to know your faculty at your university, because they can really.
I was going to just like build off of that real quick. If like, maybe you're anxious about how all this works or something, and feel like, getting like connected with faculty right away is maybe too daunting. Talk to graduate students. Like we were in your shoes just a couple years ago, so we know how it is, and we have connections too. We have our gossip networks. We're happy to be a bridge for you guys.
Also, I was gonna suggest, I know we've been talking more about like making connections and stuff, but if you're still looking for like summer programs, like international summer programs, there's this website I used in undergrad called pathwaystoscience.org. Not the Yale Pathways to Science, because I know it has something, but it's like another website where like you say like if you're a high school or undergrad postdoc, all that stuff, and then you can choose like if you're looking for fellowships, if you're looking for international summer programs and stuff like that. And you can also choose by grade, by like a year that you're in undergrad. And I remember that was really helpful for me because it would just give you, it's like a whole database with like a bunch of summer programs and RUs. And yeah, maybe I can send y'all the link later, but if you just search up www.pathwaystoscience.org and you put in like your information, what you're looking for, it's also might be like a better way of like scaffolding it and kind of pinpointing what you want to do. So that's also a thing. And I think you can also, if you are an international student here, I think you might be able to like search by that too. But I know there's different summer programs you can and can't do if you're an international student.
Yes.
And specifically like experimental particle physics, I was just wondering, like, was there like a moment that like you like, oh, I really want to do this? Was it more like a gradual thing, like I'm doing this and this, and like I think I'm really interested in? Because like I feel like the hardest part, at least myself, is like kind of figuring out like there's so many things to do, like which one? How do I know if she's the one for me?
I can say for me, like I did a bunch of different things. My first research experience was like computation, data analysis in astrophysics. And at that time I was just a pure physics major, hadn't done anything in astrophysics yet. I liked parts of it, but I didn't like, for example, like sitting at a computer all day. I liked when I could see things, but I liked the astrophysics element. And so I pivoted then and went at CERN and did this very hands-on experimental thing. And I liked being more hands-on, but I didn't really care about the research content, but I liked the like experiment group dynamic. I liked seeing more people on a daily basis. So I kind of just kept, thinking about, okay, what is my favorite parts of this? What would I, not really enjoy so much, until I feel like I found like a great like middle ground, because we're in the same group. What we do right now. It's very much, we work with people, it's astrophysics, but it's still experiment, it's hands-on sometimes, it's computation sometimes. So yeah, I think it was just like taking the parts of it I enjoyed most, but I know for everyone it's a little bit different. Some people just care about the actual research, the big question that they love, and that keeps them going. So it's very personal, but that's
my specific preference.
Yeah, for me, since I also kind of like decided finally on particle physics, I think I had done like a bunch of random research. Like I did chemistry research at one point, like oceanography research. And I think in each of those things, especially because at first I was going in straight for astrophysics, like I was doing like observing at the telescope at my college and a lot of like those type of things. And I was taking a lot of the classes and I found them interesting. But I think that once did specifically like particle physics research, and it was a small one. I think I was just building like a muon detector and building like a Python interface for it. I think like kind of like learning, I think it was like the first time that like learning the background behind something like really got me excited, trying to like learn about the standard model, like neutrinos, muons, and all that type of stuff just really got me excited more than I noticed other parts of like maybe like physics research or astrophysics research got me. Like they were all pretty interesting. Because I feel like if you're in physics, you think a lot of the different like physical, but yeah. Yeah, I think a lot of topics are interesting, but it's like really what makes you like most excited. Like sometimes I would ask myself, do I see myself researching this for 20 years? And I couldn't answer that question for like some of the research I had done. But then I was like, oh, I like particle physics, neutrinos, all that stuff, axions, dark matter. And I think that's what kind of like told me that I wanted to stay here and like continue particle physics experiments. Yeah.
For me, I did a lot of thinking about what sort of field I wanted to get into before I even like started reaching out to prospective research advisors. And I did just, a lot of like cursory reading online about what different professors at my home institution did. And when I found the page for the person who would end up being my research advisor, I didn't know like half of what his research statement said. But I found like every little piece of the puzzle that I could Google and put together was super cool and exciting. And I got lucky that I ended up finding both the big picture and the everyday, like, I do data analysis. So I found like the everyday puzzle solving of it really exciting too. And like all the different techniques I got to learn, and that was helpful for me. And also we get to do some diverse stuff. So I do mostly data analysis day to day, but I can also, like Morgan said, touch stuff, see stuff, build stuff. And yeah, so it's not just sitting at a computer 24/7. I still get to try some different things out, and there's a lot of different like ways to try things out.
I have never done experimental particle physics, so I don't really.
What excites you about like
But I mean,
your spark?
so yeah, I guess I started doing computational stuff. I started doing kind of like computational like molecular physics. And then I did an RU that was in theoretical nuclear physics, and I really liked that. And like, so I kind of like both. I kind of like the like pen and paper theory, and then also like computational theory a little bit. And like now day to day, I kind of do like a combination of both. And so I think I also like, I'm kind of right now kind of working in like kind of like a more mathy section of like quantum information. And like I found like both I like the big picture idea of like, the end goal is to quantum computations like quantum computers more feasible, like make these like devices actually work. But then like the day-to-day kind of like puzzle solving of like doing math, but also like puzzle solving of computation, I like a lot.
Yeah, so I'm pretty far from experimental particle physics as well, but what I will say, the top tier thing that you can't beat is like getting some research experience in an area. And so I did sort of 2 or 3 different REUs as an undergrad, and I think that was really helpful. Kind of underrated thing that was quite helpful is when you go to some of these bigger conferences, for us it's AAS, I'm sure there's a physics one too. I love just like, there are topics that seem interesting, but then the day-to-day is not something you want to spend your time doing. And actually, conferences are a great way of kind of like sussing that out a little bit, because just pick a session with a topic that you think is interesting. And then if you go sit in that session and the actual methods being described of like how they did the analysis to get the results for all of the different things that are in that session, if you're like bored out of your mind, or you're like, that sounds awful, I wouldn't want to have to figure that out. Then yeah, then maybe not that thing, right? And when you get to somewhere where you're like, oh, it sounds like what they were doing was really cool, and I'm both interested in the science and the results, but also the way they describe the process of doing that science really appeals to me. That's a place where you can kind of find a cool match, and that was really important for me with Astro, because it's not crazy to say that there's lots of really interesting subfields in astronomy, and from a qualitative level, a lot of them are fantastically interesting, but the actual methods needed to investigate some of these subfields are like not for everyone, or they're just very different from one another, and finding the one that clicks for you can be hard. But listening to just 1 hour of a dozen 5-minute talks on that subject can really help you be like, oh, okay, maybe not this, or oh, actually, I'm really interested in this.
In the future, does somebody who applies to graduate school have to look forward to? What's the most exciting part of what you do now?
Actually doing the research bit, discovering something that somebody doesn't know, I think is very cool. That still excites me, that there are times, not going to get a Nobel Prize, I'm reasonably confident on this side of things, but like you just edge knowledge forward and you solve a problem. You've been banging your head against it for, can be a week, can be a month, and you finally like figure out something. I think that's the cool part of it. You just know something that nobody else out there knows. And it can be very small. It's like, I've understood why this sort of tracking code wasn't working. Or that part is, and I think that you have to enjoy being able to bang your head against problems. And sort of you're only hearing talks about it seems very plain sailing, and obviously you did this, I did this cut, and it all came out, here's the result. There's months of sweat went into getting that out, and I think that it's fun. I work in an international collaboration, as we said. I think that's great. I travel the world. I've been places just back from Lapland, would never have gone to Lapland except for doing the work there. You see how other people do things, how the cultures work. I think it's great.
I think it's also easy to feel like a PhD is like pushing you into a very narrow topic area, and it is for a while. That is kind of the point. But something that I've noticed in my final 2 years of my PhD is that it starts broadening out again. And so, I came into my PhD and I was interested in galaxy evolution, and that got focused way, way, way down onto my actual thesis topic. But by the time you are graduating and you're looking at pursuing postdocs and you're building your own networks and collaborations of scientists, you're starting to broaden out again back towards whatever topic in this area is interesting to you and what you want to work on. And I think PhDs also give you, you have time to work on interesting things on the side of your primary research as well. So, I got interested in machine learning, and now I've done 1 or 2 machine learning papers with some folks, and that's been like really fun and interesting as well. And so just to say, subfield is something that you kind of have to have thoughts about as you go into a PhD, and definitely decide about at a US institution by your 2nd year. But you're not completely limited into that or into one specific project. And especially the further along you get in the PhD, the more you'll broaden out again to more different topics to work on.
And I think you don't have to be too clear, especially as an undergrad, about what is the topic that's going to be mine for life. There are clearly, as you do your research, as you go into classes, there's going to be some topics that leave you stone cold. Like, I'm glad somebody else is doing this research, not me. So that one you can do, but I think like whether I turned out to be a nuclear physicist, a particle physicist, so some of these ones into astro, was a little bit open still as I applied to grad school, and that is fine. I mean, where you go, they might be doing some research that you've had no access to up until that point. So you were unaware that it existed when you went in. So I think it's nice to be thinking somewhat, and sometimes you have, like sometimes you just know this is it, I've clicked, I'm going. But if you haven't, this is okay too. We ask you to click an area of what you're interested in. So generally you have an idea, it's the one that excited you about the research that you've done in the summers. But it's okay if you haven't decided this is my 20, 30-year career move as you apply. Being able to explain why you're interested in what you're doing because the research you did was this, but I think you don't have to have your life set in stone by the end of undergraduate. So, seems like you do. But
I'd argue for the astro programs, which tend to be smaller than physics, it can actually be a good thing too. So if you apply to an astro program where there's only maybe 10 or 12 faculty members, each with a different kind of subfield. If you are sure of exactly what you want to do, that can help you write a really strong essay. And you'll have identified the 1 or 2 faculty members that you could work with. But that can also be a situation where if those 2 faculty members don't have funding for a grad student upcoming, then you won't get into that place, right? And if you are broader or not quite sure what you want to work on, but there's like 2 or 3 areas you can identify as being quite interesting, as long as you can write about that compellingly in your essay, I think that actually helps an admissions committee say, this person might actually be a good fit here because there are people with funding who work on the things that they've identified. And so, you know, I think there can be net positives to actually not being sure exactly what you want to work on. It just kind of comes down to how you frame it in your essay.
I think Audrey had a question.
Yeah, this is a good segue actually, where when you're doing the actual writing and the sort of things that you have to think about are different from undergrad, that process, and if you could elaborate on those, please.
So basically they're saying like if the stuff you did in undergrad is not necessarily what you're thinking of doing at that graduate school.
No,
Or-
like the application process
Uh-huh.
is like you write about different things. You have to
Yes.
consider like, do they have funding for me, which is like
Yes.
not as much of a thing in undergrad. Like, are there more of those basically?
Yeah, I guess, yeah, I think I approach my grad apps just generally very differently than my undergrad apps as a high schooler. Only at a few schools that I really think I like knew the faculty and knew their situation, like was like, okay, I think, you know, I don't think at any of them I was like, oh yeah, they're definitely looking for grad students in this group that I want to be in. I did not network maybe as well as I could have, but that's fine. Like, I think, yeah, this is something we've talked about actually, but I think it's good general advice. So I was one of the people that was like kind of in between astro and physics. And I got conflicting advice about where and through what programs I should apply to at various schools, because astro is smaller, so theoretically less people going into it, but that does not mean it's less competitive. It's small, there's less spots. And then there's physics, which just a lot of people apply to, but there's generally more space. And just like you were saying, like there's a little bit, you can be a little bit more flexible if you are an astro student that has physics interests. But yeah, so I think in general, I kind of just went with writing my applications as honestly as possible about my interests, be honest, obviously. But like in terms of, you know, don't make yourself sound like, oh, I need to say that I would want to do this work when I kind of don't really want to. Like, you know, there's maybe ways to game the system, but frankly, if you genuinely want to do this research, you don't want to go to a school where they're not going to give you that opportunity. So I think if I remember, like the majority of the prompts, like for the applications across different schools were like similar, like a matter of changing a few sentences here and there, but it was generally like, what has been your research experience like? A lot of them ask like, why this school? What is it about this school's department that you are interested in? There are a few others if you guys can remember some of them, but the same general theme of questions. So I think if you are writing your essays and, you know, you're getting to that point, you'll probably want one that's sort of like, here's my arc, here's everything I did. And you do want to be specific and detailed about like, you know, I did these things, I learned these skills, I liked this, I didn't like this. And so this is kind of how I'm feeling going into this school. So it's not, you know, the way you probably wrote essays as a high schooler, undergrad, of like trying to make it sound, you know, like a story with a very like narrative thing, like, you know, you're applying to physics specific programs. you're applying and hoping that they have room for you, but you know, you're being honest about your skill set and your interests. So I think in my mind, I treated it a lot more like a job application than your typical college undergrad application. I think that's how you have to think of it also. It's not that you got rejected from a school, it's that this job wasn't hiring or there wasn't a spot for you there. So, you know.
I'd like to ask Imad, maybe to clarify a little bit what I'm hearing Audrey say, like, what are the aspects of the program itself that you should look into to see whether it's a good program for you to apply to?
Yeah. Cause definitely, you know, I agree with those points, and I think it can be an interesting shift, because even if you're taking sort of English classes and things in college, you know, the writing for a grad app is really quite almost straightforward in a sense, right? Remember that it's not you know, committee at the university reading your application, it's the actual faculty members in the program applying to. And they're used to reading research proposals for grants and things like that. And so, you know, it is okay to be to the point, and being clear and concise is the most important thing. But to your question about, you know, so what is it that you should know going in? I would put the balance probably at like 70%, 30% of like 70% is your arc, your story, something that doesn't really need to change from place to place. It's stuff that everywhere needs to know about you, right? And then 30%, I would take some time, especially at the places that you're most interested in. There's a trade-off. It'll cost you more time, but it'll help your application a lot to do that sort of customization for those schools. I think bare minimum, you need to identify 1 to 2 faculty members that you're most interested in working with, actually know what it is that they work on, and have that be up to date, which I would not trust their websites for. Absolute best way to figure out what someone is working on is archive. So just pull up the latest papers coming out of their group, their grad students or them, and just see kind of what it is they're actually publishing in the last year. That's also another way to sort of gauge if they're taking students, right? Don't play the game of actually trying to figure out if they have funding, because it varies year to year quite dramatically. But like, if they have students who are publishing over the last couple of years pretty consistently, then that's a pretty good sign that they are consistently working with students, and the students are consistently being able to publish. And so, you know, I think from the committee side, there was 2 kind of breaks that happened. One was if there really just wasn't any personalization towards our program at all, that immediately downgraded applicants by a lot. Not just because, you know, it almost felt a little egotistical of like, why do we have to make you say why we're so special, right? But part of it is also that it becomes really hard to assess whether a person is a good fit for the program if we don't know, you know, where they would slot in, right? So then the next step was like a large number of applications that had a sort of perfunctory 1 or 2 sentences slotted into paragraph 3.5 about Yale. And, you know, that's fine. I think that's the minimum that one would need to do. But the ones that really stood out were the ones that very clearly had done some research into the people they wanted to work with, that it made sense in the context of the story they were telling in their app. And that didn't necessarily mean that what they did as an undergrad was transitioning perfectly into who they identified. It could be, but it could also be they told a story about what they did, about what drove them to want to change to something different, and then why these faculty who do something very different were the ones that they really wanted to work with. And I think the right balance was usually somewhere around, you know, 2 or 3 faculty that have a slight range in topics. And then maybe if you have a statement about whether your interests are broader than that, if those faculty aren't taking students, right? Like, I'm also interested in these topics, and you have a strong representation of those topics in your program. And I think if you can do all of that, then you're doing pretty well in helping the committee assess whether you'll be a good fit for the program.
I think it's very easy to make it make sense and make it sound honest if you actually are interested. So yeah, that's why I always advocate for be honest.
I was gonna say, for me, a significant part of my application was the outreach work that I had done in undergrad and wanted to continue to do in grad school. So for each program I applied to, I went through their website and looked at what like extra programs they had. So for instance, Yale had our Women in Physics group, which has since been renamed. They had like a queer physicist group. We have all sorts of stuff here. And so I was able to kind of talk about how I wanted to get involved in those as well. And I'm not sure from a committee side how much that helped, but I think it at least made my application more honest and open.
Definitely. I mean, I think that signs of personality that way and people identifying what they care about really matters. But I think also, you know, we're not just looking for people to be students, right? When you're a grad student, you're like a part of a department community. And it will matter to at least some people on the committee that you are interested in contributing to that community in different ways.
Do you want to say something about that?
No, I mean, I think that I know this keeps coming up a little bit, but sort of not necessarily misrepresenting yourself, but sort of overinflating things that are not quite like a good reflection of you is just going to put you in a place where you're like, what are you going to do there when you're not actually the way that you say you are, right? Or like the person you wanted to work for, you really wanted to work for is actually not accepting anyone, then you're stuck, right? So I think that the honesty that you place into your statement is more than just showing like what you're capable of, what your skill is, but it's also like getting you into a place where you're gonna be happy, right? So like if DEI is your passion and you write about it and it goes to a committee that's like, well, this is not important, then you're not gonna be happy at that place, right? So I think it's important to be, to just show who you are. And the more you can do that, the more likely you'll land in a place that, is gonna gel with you and make you happy.
Yeah, bouncing off of that, I was gonna say that's really important. Because like Morgan, something that's really important to me is DEI and that a department at least shows that it's trying to better itself and like show initiative and those type of things and has opportunities for me to get involved. So something I think there was like some schools that I think I had always wanted to go to, but then after researching them, it seemed like they didn't really care about like the things that on a personal level I cared about. So if like I went to a school's website and they didn't really have like a statement or didn't have like any outreach programs and stuff like that, I knew personally I wouldn't be happy there because personally for me, I can't do STEM without some diversity work. Like I can't just be one of those STEM heads. I need to have, unfortunately, I cannot. Unfortunately for me, like I have to be doing something like something within the community at least. So I know something that I specifically like about you is that at least like in the community, I can go out and like interact with the community or just do outreach with all of the different outreach opportunities. So I just like sometimes just even like like there were some schools that I'm like, oh, I always wanted to go there. Like, oh, it has such a good name. But then I'm like, okay, I just didn't apply there.
There was even like some small things that I noticed literally just filling out their application. Cause one of the essays that I think pretty much every school in some capacity asked for your DEI statement. Or like, a word, saying what you did for outreach and that kind of thing. Some schools had those as like two completely separate things. Like, I think there was even one, I'm not gonna remember the school, but it was like, say only your research skills and interests here. And then in this completely separate part of the application, you have like 3 sentences on why you care about DEI. And I was like, I don't like these vibes. Like, for me, it's all one essay. It's all one story. Like it's all part of my art, my outreach and my DEI interests were all part of my physics. And so even just in the way that some of the essay prompts were stated and some of the applications were formatted, I could tell how much they actually cared to hear that from me. And like, weren't trying to limit that and exclude that from whatever my actual science is. So you can tell a lot from like the vibes of their website and their application if that resonates with you or not.
Although I will caution that at the website, definitely, the department's website should be centering things that you care about. With the applications, it can be a little bit tricky because sometimes departments don't have full control over
Yeah.
the way the applications are set up and formatted. That's a problem we have here at Yale. We're trying to change the Astro app and everything has to go through the university and it becomes a pain. But I mean, I think my flip side to that is just at somewhere less than 10 places, you know, however many you kind of decide, where you're really kind of focusing your efforts. Reach out to a grad student. I mean, honestly, they'll spill all the tea. They'll tell you everything you want to know about the climate of that department in general, and also what are the availability of programs to get involved in or things the department's doing that you can be a part of. They can even, you know, tell you who is or isn't been working with students. I mean, there's a lot of information that you can get if you just do one Zoom chat with like a grad student at that program. And I guarantee you 100% there's a grad student at every program who's down to chat.
Yeah.
And so, and I would just, you know, honestly pick a random one, email them and be like, and if you don't have time, would you just post this on your department Slack and see if anybody has time? And doing that early and having that information at your disposal will both help your application and also just help you decide if it's even a place where you want to apply. So I highly recommend doing that.
My question is, did any of you apply for the NSF GRFP fellowship? And if so, what were your reflections from that process?
I thought that it was good to do almost no matter what at the undergrad level. The pool is less competitive at the undergrad level, and it gets you to write a draft version of what will be your grad applications by October 20th or whenever the deadline is, which is great because it's very easy to procrastinate. And so having something that is done by then is great. And I actually ended up rehauling my application completely. I almost rewrote my essay from scratch after the NSF deadline. I didn't like it anymore. It had gotten workshopped into infinity and whatnot. But I wouldn't have even known that if I hadn't finished a version of that and got it submitted somewhere. And so I think it's worth doing almost no matter what. And if you do get it, it is a great source of funding, can really give you a lot of flexibility in your grad career, because if you have a faculty member who may not have 5 years of funding for you, they don't need to, you have your own funding. And so that can really be helpful. So yeah, I think it's definitely worth applying. And I will say that my impression over the last couple of years has been that applying as a grad student is quite a bit harder. Because only senior undergrads are applying, but both first and second year grad students can apply, and you can only do it once. And as a first year grad student, I would say it's almost nearly impossible, because your research proposal has to go up against everyone who just did their quals. And so they have a really good research proposal definitionally. And well, depends on what you call this, I guess. There will be a lot of people with very, very strong applications in their second year. And so, you know, then you're waiting until your second year to apply, but then that's your last chance. And in any case, I recommend applying, and I recommend applying as an it would be my takeaway.
I totally agree with what he says about start early. This takes a lot longer than you would have thought it could possibly take to do these applications. And it is, I forget who said it, but it is a job application. It's not a continuing school application, even though it is continuing school, it is a job. You think you work hard as an undergrad, grad school is even harder. Probably gets harder from then onwards. So I think like starting early, getting as many people as possible to read through it. We've read a lot of these applications by this point, and you can tell when it was dashed off last night. It doesn't necessarily be a death knell, but personalizing it is good. And if you've got MIT and the one that you send to Yale, it's not a good one for you. Can't tell you how many of these we read that they really want to go to MIT. It's like fantastic, go to MIT. So I like just proofreading it through, reading it again, get your friend to read it. No, like you can't do this and start early enough. And applying to the NSF is a way to just kick your butt to get started. We're all good procrastinators, so I think that is a good
So
way.
getting grads and faculty to give comments on is great. I was also just going to mention, compared to grad apps, NSF you can go find successful applications. There are like libraries and catalogs online where people have submitted and allowed others to look at their successful applications. And so, you know, I would do that to an extent of, you know, you don't want to end up in a position where you think you're mostly just repetitively copying them. But there are certain things with the NSF, like broader impacts that you kind of just like have to get right. And seeing examples of what the NSF committees were looking for. So that's just a resource that's available. I think Alex Lang had a website that
Yeah. I have nothing, I applied to NSF, I have nothing really else to add, like, great job summarizing basically everything about that. About applying to like grad schools, I do wanna add, reach out to professors, like reach out to professors you might wanna work with, like, you know, that can clear up whether or not they're taking students or not, you know, that can like clear up a lot of these questions that you might be able to suss out of the department website, but obviously the best source is from them directly or from students who are in the program. Yeah. And that can also help your application if you have a professor in the program who is advocating to like admit.
Yeah, that's exactly what I was gonna say. It'll always help if the professor recognizes your name in the stack of applications.
But I think the key thing is to start early. Because especially if you're gonna try to apply to the NSF while you're also applying to grad schools, it can become a lot. So even in the summer before, to like write down like maybe even like a bullet point list of like what you're thinking of writing for the NSF, and then maybe at the same time start writing like the research that you've done, even like in paragraph form, can like set you up well for having an easier time, like when you're applying to grad school in your senior year.
Maybe another hack is to make an appointment with someone like a professor who's gonna read over your application. Cause that's really helpful, but also you have to get it done or have a draft at least by that date. If you're one of those people that need something to hold them accountable like me.
I used to tell one of my mentors that if I didn't have something done to like be very disappointed in me.
Yeah.
Tell that to my face. Or else I would just like procrastinate. So if you find someone like that, you can't tell them to be like, be mean to me and yell at me if I don't get it done. Then that's also good if you need those extra deadlines.
And you do have to have letter writers.
Yeah.
I guess cultivate more than one person.
Yeah.
I think you need
Three, yeah.
I mean, 3 minimum. So that means you need 3 people who can say something more than she sat in my class at some point.
Yeah.
And so get to know them, because we don't want to really read that you got an A in this class. And if that's all the faculty member can say about you, that's almost not worth writing the letter. So again, turn up at their office, talk to them, talk to their grad students, talk to their postdocs if they're there, so that they are aware that you're thinking of going to grad school before you turn up in their office. And it's nice to turn up in person and say, could you write a letter for me? And please phrase it as a request. Sometimes you get the email saying, write a letter for me. And like, we will generally do it, and we would really like some time to write this letter, because you want us to write something personal about you, which means I need more than 24 hours to write that letter. You would be surprised. They're like, oh, and the deadline came up. It's like, well, you've known for the year the deadline is coming up. And again, we will scramble because we want you to succeed, but a scrambled letter for me is not better than, I mean, I will probably write it at the last minute, but at least it's been my problem, right? I'd be amusing about it. You need time for them, so talk to them when you're starting to think about it. They can even suggest places that might be of interest to you. But you do need to cultivate more than one person.
Also be aware that most of the time on your applications is going to be spent like editing. Because the hard part is actually somewhere, like you'll have done a lot of stuff as an undergrad, and the hard part is fitting that in 2 pages or 3 pages potentially. And so, you know, cutting, making it as compact as possible while getting all the information across. That's really hard.
I just have a quick question. Could each of you guys tell me what you love about your research and like what really gets you riled up about what you do? Because I'm just interested to hear like what keeps you going on the day. That's a great question. Day to day, just knowing that I'm working towards like cracking a big puzzle?
For me, I'm working on like a newer experiment, so it's still like in the R&D process. So I think like working with like specific devices and like working towards something that's gonna like be a central part of like an experiment when like it actually starts running is something that's been really exciting. And yeah. Currently, yeah.
Yeah, I think similar for me, like, I think it was mentioned earlier also, like, I get really excited when it's like, okay, no one's done this before, no one's gotten this to work or built this thing. Or like, oh, I took all this data, I'm really curious to see what it looks like. And then it's, yeah, definitely frustrating process when it doesn't work, but that kind of just makes you even more like determined. I get very like tunnel vision on things. And it's so rewarding when something actually works, so.
They don't send you the full data.
Yeah, when I get my data, that's also.
I think for me, it's similar, like, you know, you're solving like a big puzzle, like you're banging your head against the wall for hours, days, trying to figure something out. You finally figure it out. It's great.
Yeah.
It might suck. You might be like, damn it, I can't get this to work, and it works. But I think the best part is definitely when you can explain something that like no one's ever explained before, or like something like I don't know, like, because I do theory, so like we see some data in like someone like made some measurement with like a superconducting cube, and they're like, oh, what's this weird pattern? And then you're like, damn, we can explain this. And like when you're able to like do that, it's really special.
Yeah, you will be the expert in something a lot faster than you think you will. That's kind of fun.
And it's really fun to just talk about particles with other people who really like particles.
Like on that note, I'm surprised no one said conferences on the Italian coast side. Well, I think, so my kind of research is in 3 different pillars, and I get something out of all of them. On the one side, I like developing software packages for the community, and that's where I do most of my banging my head against a wall and trying to figure something out, is like how to write a new code that does something. And also for analysis, but not quite as much. In the center, I think the thing that I really love about the science that I do is getting to use things like JWST or fly to Hawaii and use the Keck telescopes in ways that they haven't been used before to try to learn something new. And yeah, just getting to work with world-class data from world-class facilities has been really special. And you know, there's not many things that you can point JWST at or Keck at and not learn something new. And that's just how amazing those facilities are. And then the third part is more like an instrumentation side. So our group is building a sort of multi-telephoto array telescope thing, which is aiming to detect gas in the circumgalactic medium. But for that, you know, I've actually gotten to go like bolt things together and, you know, build an instrument and try to use it. And so I think that's been a fun, like, hands-on aspect. And also just a lot of ownership, like, wow, we've built this thing together and it can do something that nothing else can. So that's really what.
So I saw 2 questions from people who've already asked questions, which is fine, but is there anyone who hasn't asked the question and wants to ask?
Yeah. So I was wondering, what's the biggest difference between your undergraduate study and your graduate study? Because a lot of upper level undergrad do both research and class, and I assume first year and second year graduate students take classes. So is there like any big difference between taking classes and doing research as a graduate student?
Yeah, so I would say for me, the biggest difference was how much more focused I am on physics. In undergrad, you know, I was still in my 3rd and 4th year, I was still taking upper level physics courses and stuff like this, and I was doing more advanced research. But I was also, you know, I took women and gender studies classes or law classes or like you know, that kind of stuff to kind of mediate everything, so I wasn't losing my mind over physics homework 24/7. And I think I had, you know, more time for hobbies and things like that in undergrad, whereas in grad school, you are really laser focused on physics, for better or for worse, probably for both. And it depends on the structure of the program you go into. For instance, here at Yale, the first year is very course heavy. At other universities, it's more balanced between courses and research all the way through. That's just something you'll have to talk to programs about on your open day visits or when you meet with prospective PIs or something like that. But yeah, I'd say overall it's a lot more late.
Also, the teaching makes a big
Oh,
difference. Going from undergrad into grad, it was like, yes, I'm still taking some classes and still doing some research. Although you'll find, the research will shift into more longer outlook kind of project as opposed to more self-contained things. The classes will depend on the program in two senses. First, like you could have anywhere from 5 to 12 classes in a program. It varies hugely, and so how much time you're spending on classes will vary. Also, the degree to which the program emphasizes the time that you should be spending on classes varies. And this is maybe more true in Astro, I'm not sure, but there are a lot of programs in Astro where the classes are sort of like there, but like the expectation is that you're focusing primarily on your research and not spending a ton of time on classes. So, at Yale, we have our grading system is like H, HP, and P. And that's kind of the only things you can get, like an honors, high pass, and pass.
Yeah.
And so, there's not quite the same emphasis on like numerical grades and things like that. The classes are there to give you tools that you might need in your research. And then lastly, you're suddenly going to spend time teaching. And so, grading assignments or teaching sections, those kinds of things will also vary institution to institution, but you will, especially in the first few years, be spending a fair amount of time in those kind of teaching roles.
You're also expected to be a lot more independent.
Yeah.
I mean, as an undergraduate, even if you're doing a research project, the person will be there quite often saying, and the next thing you should do is, and then come and show me this box, starting to move as you head into the senior. But once you're in grad school, it's like, do something, and I'm around, but I expect you to be self-motivated to be coming in. I mean, we expect you to put in hours, but I'm not gonna check on you that you're in the office. You need to get the work done, and so do it. And hopefully you're enthusiastic about it, right? This shouldn't be a chore. Some weeks it's a chore for sure, but and we'll expect you to come to their office or the PI or the postdoc or the senior grad student and say, I'm stuck. Here's some ideas I have. And then we'll discuss, not I'm stuck, solve for me. I think that's heading to be the difference. And that's the fun part of it too.
Yeah.
You're inventing your path as you go.
Yeah, I think. Let's say Andrew. Question.
I just kind of want to wonder, like a grad perspective, how to look upon if you have like 5 or like 10 years from like when you were an undergrad to like go into like grad school specifically for like military, like afterwards.
Are you saying like there's a large gap between undergrad and grad school? Like you
Yeah,
take
yeah.
a lot of time off?
Yeah, specifically how, I don't think that the experience of like taking on like a time off or because from grad perspective, how does it look like when you take a long time off? If you have like very commitment after undergrad and haven't done research.
I think as long as you can explain why you were off and what you were doing, it's not a big problem. I mean, it'll be a bit of a culture shock to come back to classes. Sort of like, once you stop being in classes, I wouldn't want to take classes again. But I think if you can explain why you had a break and it wasn't just even if it was, I just wanted to go and try out in industry, you have to then explain why you want to come back. But I think if you've been doing military service, I did military services, that's sufficient enough statement,
Yeah.
and the rest of yours should be explaining why you want to be in grad school like everybody else.
I mean, we've definitely had people who went to industry, we've had high school teachers in our program. I'm just thinking of people that I'm remembering from the past, like, I don't know, maybe 10 years. Someone who is actually not, I can't remember his name. He was actually teaching at a military college.
Yeah, I had 2 students who
Yeah.
come from military service.
He was a faculty there for some time.
We have an incoming grad student in Astro this year who is a veteran. So Marla in the Astro department runs something called the Warrior Scholars Project. which is like a 2-week summer boot camp to help veterans who want to get back into academia, like brush up on coding skills and stuff like that. And one of the students who participated in that program applied to Yale and got in this year. So it's definitely something that can be a part of your application and is not a detriment to getting into a program.
You have another question? Yeah.
Sorry, you.
Yeah, like, so what's the advice on applying to an astronomy versus physics department for astrophysics interested people?
I mean, I give my 2 cents, but I've never been on an admissions committee, so I'm not an expert. I ended up applying, since I was a little bit in between, through physics departments, because even if they had a separate astro department, there's still like a section, you select a subfield of physics that you're interested in. And astrophysics cosmology was still always one of them, even if they had a separate astro school, except for maybe at like one school. So that's what I ended up doing. And I think the advice that I got of apply to astro because it's less competitive was not good advice. Yeah, I think that was advice from many, many years ago, where smaller actually meant less competitive. Now it literally just means smaller. So yeah, that's what I ended up doing because that was also true to my interests. But if you truly are pure astro, say what I said, follow your interests.
So I worked in the astronomy department before I worked in the physics department, and I would ask, why did they have two? Because the astronomy department is very independent of the physics department, and they also join together, but there's a reason they exist separately. So I would find out why and see if that resonates with you.
Yeah, I think there's two big things. The first is, do you want to spend your first 2 years taking physics classes or astro classes? Part of my decision was honestly that I did not want to take quantum again at the grad level. And so I was like, no, I'm gonna have to do that in an astro program. But the other thing was that, my figuring out what programs I wanted to apply to was driven by people I wanted to work with. So I went to my undergrad advisor and was like, who would be the best, PhD advisors for me anywhere in the country? And they threw out a list of 10 people, and I looked up people that I had written papers I thought were cool. And from that list, that's where I got my list of institutions. And at those institutions, those people were either in a physics program or an astro program or a joint thing or something else. And that kind of was part of what went into that decision. But yeah, so I would say, there's also the case of cross-listed people. Like, so here, there are certain faculty who are cross-listed between astro and physics. And I think, figuring out, there's usually one channel from which they're getting most of their students. So, figuring that out at different places can be a little bit complicated, but I think for me, it was mostly that my research interests were ones that tended to be people on the astro side and not cross-listed with the physics side.
But I think there is no right answer.
Yeah.
Like it will vary for you, university to university, as people say, and we will pass them on. If you apply to physics, we pass them on to astro. If your application was more suitable to the astronomy, then we read it through, and vice versa. So there's some internal shuffling if you're really on that narrow edge. So I think just looking as they were saying, who is the research in that subfield, which group is it in, is what you should look at. Who do you think you'll be like better fit for? That could vary application to application, not just person to person. Like trying to game the system. It's not worth it. I don't know. It's like, you'll end up somewhere where you're miserable. I mean, you gamed the system, but did you win?
Yeah, people often ask this question with physics and applied physics, because there's a lot of cross-listed people, and we have also some people who are like joint, like completely joint appointments. And I think that in those cases, I think that the leading thing should be who you want to work for, but if they're spread out over both departments, you might want to take a close look at the program and just see, and like how you would with like two different physics programs, and just see like, well, this one has these kinds of requirements and this is their timeline, and that sort of schedule sort of I'm more excited about that kind of schedule or that curriculum or something like that. I think that's another way you can figure out which place to apply to.
Yeah, I'm gonna jump back to funding. For graduate studies and for the jobs following graduate studies, what does salaries, compensation look like? Because I know I'm a first generation locum student. Is the trope of broke graduate students still applicable today?
It depends where you apply.
Yes. Or, yeah, that's what oh yeah, I was gonna say, it really depends where you apply. I think if my experience here, it's been pretty doable. I think it's pretty good now with the raise of the union. It's been pretty good, but I do remember some other schools, especially like in the Midwest and stuff, they pay you like 28,000. It really does depend where you go in the cost of living, specifically in that place. Definitely compare those costs. Like, yes, the stipend, and maybe it sounds high, but where is it? Is it in Los Angeles? Because then you need to adjust for that.
Yeah.
And there are some where it really doesn't match up, that I don't understand why certain schools do that, where the stipend is low, but it's not a low cost of living area. So it depends, yeah. But I definitely don't think we're starving. I mean, we're definitely not starving. I don't know if any grad students are truly starving. You have enough money to live on.
Yeah.
If you pick the right school.
Yeah.
I think that's what they're saying. I mean,
Yeah.
as a physics student, you should be able, at least as a single person, be able to live okay. You're not gonna be buying a house on your graduate salary, but you should be able to rent a decent place
Yeah.
and live. And if the salary doesn't do that, don't go there. I think there are places where you can. You gotta look at the cost of living, because it might seem like a low number, but the cost of living isn't so much, and vice versa. But you shouldn't be not able to afford to live.
I think, go ahead.
Yeah, like $25,000-$30,000 a year in like rural Indiana or like Midwest somewhere is much different than $25,000-$30,000 a year in like Los Angeles, Seattle, New York. It really depends on where, on the depends on the location. And a lot of programs,
Yes.
Yep.
and a lot of programs might adjust their stipend based on the cost of living in the area. So like, I would generally expect places in big cities to have a higher stipend than places like in really rural areas, but it also just varies. But sometimes they don't. Yeah, some places might be in a big city with a really bad stipend that you have to live with like 8 roommates. And some places you can have your own place.
I think the variance in the US is a lot lower in the sense that once you divide stipend by cost of living, I think almost all US institutions with an astrophysics physics PhD program are providing enough stipend for you to live on. Although I think the primary point of variance is like, do you need a roommate or not? It's sort of the vibe, right? Because cutting your rent in half is like a huge change in your expenses. And so, you know, when I was at Berkeley, like Berkeley grad students were very often sharing an apartment because the Berkeley housing market was terrifying.
Yes.
Here in New Haven, I think if you want to save some money, you can live with a roommate, but you can also find a place that you can live yourself on Yale's salary.
But it's more like a housemate.
Yeah,
Usually
you
that's
usually
better.
have a house here and a housemate. And yeah.
Yeah.
Well, on the other hand, my Toronto grad student friends are struggling. And there are some grad students I know in Europe who are also quite struggling. So, you know, my anecdotal impression at the current moment is that probably at most US places you apply to, you should look at the details, but on the whole, you don't need to be extremely worried that the stipend will just be below the cost of living somehow.
Yeah.
But internationally, I would look even more closely.
Okay, so it's almost 2:30, so I'd like to wrap it up at 2:30. Are there remaining questions? Yes.
It's just like a small one, like that'd be small if you guys could think of like one thing that you think stood out in your application that maybe different and helped you get in and gets the guys on the panels and what you think makes a student stand out and you quite fun in similar background.
Sorry, you dropped off at the
sorry,
end.
just like what you think makes someone stand out in an application.
Yeah, it's kind of hard to say from our side.
Yeah.
Say, but I think talking about who you are as a whole really helps, because you're not just a brain in a jar that does computations all day. You're a person who does a lot of different things. So, for instance, I talked about the volunteer experience I did with my figure skating team. And just like small things like that that can make you different.
Yeah, I think it's really hard to know. Like, I don't know why I got into the schools I got into. I probably couldn't know, but one of the better pieces of advice that I got, which I think is something I emphasized in my application, was like, when you're doing research, being a graduate student is not the same, as we've said many times, as being an undergrad. And I think one of the biggest things is that, you know, you need to be independently motivated. You need to be okay with getting stuck on things and struggling, and you need to pick yourself up from those. So emphasizing, you know, moments where if you maybe didn't have the best grades or you struggled in some way in a research experience, actually emphasizing what you gained from that. For me, I emphasized the fact that I did not do well in a lot of classes, but I still wanted to do physics because I wasn't deterred by setbacks and struggles. Yeah, to show that you're a resilient person and that you're not constantly reliant on validation, because you're not going to get grades and scores back to make you feel like you're doing a good job. It's up to you. So I think that aspect, if that's part of your story, that I think is a great thing to point out. You don't have to act like you were perfectly good at everything in your application.
Yeah. I think because you're applying for the program to do research, and you want to be able to be good at that, but you also want to sell yourself as like a good person to work with, like, because you're not going to be like sitting in like your own office doing stuff by yourself over 6 years, 5, 6 years. You're going to be working with them. You want to sell yourself both as like a good researcher, again, passionate about what you want to do, but sell yourself as also someone who other people would enjoy working with. And I have some anecdotal advice. I take this with multiple grains of salt, but definitely reaching out to people like professors you might want to work with is a huge help. Anecdotally, I got into 100% of the places that I had some point of contact with people, and I got rejected from 100% of the places that I didn't. Not saying that's going to be everyone's experience, but it certainly helps when this is also playing into like that someone knows you as a person rather than like just a piece of paper and some numbers and some words.
I would definitely second the thing about being open about hardships and how you push through them. I think the term often used on committees is grit, and it's something they do actually want to see. I think from my reading of applications, I think something that maybe isn't talked about as much that does stand out to us is when you're describing the research that you've done, it's very easy to go too high level or too low level. And so if you go too low level, you're really describing the weeds of the project and like belongs in really the methods section of a paper about that thing, but is not helping the committee very much. At the same time, if you're sort of way too high level, you're not sort of adequately displaying that you have like a really firm grasp on what it is you did. And so there is a sweet spot to hit where you're talking about your research with enough specificity that it's clear that you have a handle on what you were really doing, but that you also have that broader understanding of where your research fits into the broader scientific context and why that's interesting. And so, thinking about it less of like, I need a laundry list of everything I did in research, and more, if I were writing like a scientific proposal for why the project I did would be interesting to fund for someone, that kind of mindset can help you be like, okay, this is why we did this research in the first place. And I think if you can articulate why the research that you did was interesting and what you gained from it, while also just, demonstrating your mastery over it, then that does a lot to stand your application out, along with everything else people were saying about, also being a human, coming across as a human. I'll also say I'm very shy about, I found it very uncomfortable to try to like gas myself up in my application. If that's something that you struggle with, having others read your application and tell you when you're being a little too harsh on yourself and things like that is valuable. But the other thing to remember is that your letter writers are there to gas you up too. And so, you know, if you have this conversation with when you're asking people to write your letters, know that the goal of them writing you an enthusiastic letter of rec is that, you know, they'll say the nice things about you so that you don't have to find a way to say a bunch of nice things about yourself. So yeah, those are the two things I would say.
Oh, you have anything to add?
I know a lot, I think they said it, like, I am looking for a person, not a robot, I guess, like. There's a big difference between being book smart, which got you straight A's maybe as an undergrad, and being a good researcher, so I think sort of focusing on that. And people have said a lot of it, being honest. Sometimes you read them and it sounds like they think they were the spokesperson of the experiment. It's like, you're an undergraduate, I know you didn't like design the experiment. I mean, you did valuable contributions, so selling yourself but not overselling, I think is because I'm gonna be stuck in a car with you for like 10 hours, at least once. This is gonna happen. We're gonna drive somewhere and be in a traffic jam, and I want someone who can hold a conversation with me on this bit, right? So I think that is also a little what we're looking for. So some of what else you've done. This shouldn't be a major part of it, but that there is a human being in there who can make conversation about something other than research, I think is good. Clear. But I guess we don't want to be reading at the start that you've been interested in physics since the age of 3, and you know, grandpa brought me the book at age 7. Some of the things like really sort of what have you done recently? What did you learn from it? Even if it went wrong, that's fine. Research goes wrong a lot. We've said you don't have to publish, you have to have learned something along the way.
And another argument for being honest is like, and human is, at the end of the day, once you're past the sort of long list, which is usually about 40 to 50, at least in Astro, it's sort of a crapshoot at that point, right? There will be a whole lot of luck at play because really the top 20 or so candidates for any program are all fantastic. And some program requirements and who has money and things will determine some of the order. Some will be faculty member knew someone, they met someone and they want to push for them a little harder. And then the rest is just absolute luck, right? And so at a certain point, you know, you can't game the system beyond that long list anyway. And so, you know, just kind of be yourself and then apply to enough places that you think you have a reasonable shot of having some good options. Although, yeah, to your point, I think anywhere where you have a personal connection that you can draw on will help your chances a lot because you'll write a more personal app and the connection is there. So those two tend to help a lot.
Right, I'm gonna close up this session, but these people aren't going anywhere. They are here all summer or unless they're on vacation first, but they're accessible. So you have their names in the latest email I sent, should have all of them. And so feel free to ask them any questions that you have remaining. And I want to thank them for their time and thank you.
Always around and always willing to talk about stuff.
Yeah.
So come find us, come bother us.
Yeah.